am going to do a tour de force through the neurobiology of addiction and principles of effective treatment. In my interactions with you all today, you have lots of questions, many of them focused on treatment, not so much on neurobiological underpinnings. But I'm going to spend a little bit of time briefly talking about that because in a very macro sense, speaking to one particular neurotransmitter and one particular part of the brain and the reward system, because we don't have time to go into all of it. And it's really the understanding of that part of the brain that's informed a lot of the work that we've done in developing treatment so far. So does anybody know who this is? So this is perhaps some of the early images that individuals have or that the media has portrayed about the interaction between the criminal justice system and someone struggling with a substance abuse problem. So this is from the Andy Griffith Show. This was the local alcoholic, right, who was in and out of the jail there. Who some may not realize was also initially introduced to the show through his arrest for domestic violence that was certainly related to his drug use. Over the course of the show's history, if you paid attention to this character, you learned that he had a father who was an alcoholic. He had a brother who lived in the next county over that spent time in and out of that jail system and was an alcoholic as well. And does anybody know how his story ended? So his story ends with him leaving the show for a period of time and then suddenly reappearing. I like to think he went into treatment because he comes back and becomes a successful member of that community, not drinking, not going in and out of the criminal justice system, and actually eventually opening an ice cream shop. So we know that drug use has widespread consequences, medical consequences, economic consequences, consequences for our society, and addiction. And I'm going to spend time talking today about addiction. I'm going to try to help answer the question, well, what actually is addiction? Our research is indicating that addiction is a developmental, and I'll speak a little bit more about that, brain disease that's expressed as a compulsive behavior. The hallmark feature of that compulsive behavior you all know all too well, which is the ongoing seeking and use of drugs despite, in many cases, very negative consequences. Our evolution in technology has allowed us to really understand addiction as a brain disease by looking inside the brain to see what's happening. These are images from PET scans. At the top, you will see the image of a heart. On the left, you'll see a healthy heart where there is lots of activity and metabolic activity taking place. To the right, you see a diseased heart where metabolic activity has been compromised. Similarly, we can look at the same kinds of things within the brains of those who are suffering from drug addiction. On the left, you see a composite of PET images of a control subject who has not been exposed to drugs of abuse. All of the light colors, particularly in the front part of the brain, which is the prefrontal cortex, responsible for lots of important functions, including judgment, decision-making, weighing consequences, is nice and bright and indicative of healthy metabolism. And to the right, you see a composite image of a cocaine addict, where that level of metabolic activity is much less and has been decreased. We see brain differences across all of the drugs of abuse. I could have put up an image of tobacco for nicotine addiction. There's alcohol, heroin, methamphetamine, cocaine. This is looking specifically at changes in the level of dopamine, D2 receptors. And so what's important to know, first of all, is that all addictive substances, repeated exposure to all of them can change the brain. And especially when it comes to the dopamine system and lowering the level of D2 receptors. Remember, those were like the little catcher's mitts that were explained to you all this morning. We think that lowering in D2 receptors is a part of why drug users are chronically seeking drugs. They take more drugs in order to experience a similar high, and while naturally rewarding activities that you and I would participate in that would give us a sense of well-being have little meaning to them and to their brains. So what do I mean when I say addiction is a developmental disease? You've seen the slides across the bottom that talk about the way in which the brain changes and develops over time, front to back, inside out. Well, first of all, initiation of drug use peaks during adolescence. Adolescence is a time of experimentation. It's a time of seeking the novel and the new. It's also a time where individuals may become aware of things like anxiety or depression, and they're trying to figure out how to compensate for those intense feelings. It's a time when peer pressure and peer influence is tremendous, and parental influence can become less so, and parental supervision may be less so. All of that leads to initiation. Because of all of the changes that you learned about this morning that are taking place in the brain, the pruning, the developing of circuits, the myelination, all of that means that the adolescent brain is particularly vulnerable to the toxic effects of drugs of abuse. And so if exposed, and if exposed repeatedly, an adolescent is more likely to progress to a substance use disorder than would be an adult. So I'm going to back up for a minute, and I'm going to talk a little bit about some of the, well, is it the nature, is it the nurture, is it both? It's extraordinarily complicated. Addiction is a product of biology, genes, and environment. This is data that is from a large study that was done in New Zealand, where they collected information on over 1,000 individuals. They began assessing these children at the age of 3, and they were looking at their level of self-control to determine whether or not level of self-control was going to be important in predicting outcomes in 3 really critical areas: health, wealth, and criminal behavior. Now, the interesting thing about self-control is how conscientious we are. It is the ability to control your impulses, to regulate affect, to delay gratification. Self-control is malleable, and we've developed effective prevention interventions that can be delivered to children in order to help improve their self-control, which is also a very important thing to know. And what they found is that when they followed these individuals over time, beginning at the age of 3 all the way into their early 30s, that you could predict health, wealth, criminal behavior, substance use, whether or not you were going to be a single parent rearing a child alone, based on your level of self-control from low to high. So if you have low self-control, you're more likely to have numerous health problems than if you have high self-control. If you have low self-control, you're more likely to have issues with wealth than if you have high self-control. You're much more likely to have financial problems, poor credit, not own a house. And also, if you have poor self-control, you are more likely to be involved in criminal behavior than if you have high levels of self-control. So this is an important prevention target. It doesn't help you with people by the time you see them within your particular courtroom, but it has critical implications for what communities can do in order to help improve the health and well-being. So this is a little bit about environment. This study looked at over 8,000 individuals, and this was a prospective study. So these were adults. They asked them to reflect back over the experiences across their lifetime. They were trying to get indicators of adverse childhood experiences, including things like neglect, physical abuse, criminality of a parent, drug use of a parent, family discord and strife, mental health problems of a parent. In the home. And what they found is that for individuals who acknowledged ever having been addicted, those who had more adverse childhood events were at greater odds or greater risk of ever developing some type of a substance use disorder. Again, sort of underlying the fact that this is a complicated picture of environment and biology and development. So I'm often asked this question of, well, why can't addicts quit? Why can't they quit using drugs? You know, they've lost everything. I'm going to have to put them in prison again. Why do they keep doing this over and over and over again? Well, I'm going to tell this story in a very simplistic way through a single neurotransmitter, dopamine, but all of the neurotransmitters that you heard about this morning are implicated also in addiction. Dopamine is something that we know a lot about in terms of its role with regard to addiction. Dopamine is kind of like the brain's primary pleasure chemical. If your brain neurochemistry released little smiley faces, that would be the dopamine, the little smiley faces. We experience feelings of well-being, of pleasure, and of accomplishment whenever dopamine is released. Dopamine plays a very critical role in our brain and in our behavior. It is implicated in attention, problem solving, coordinated movement, and the anticipation of reward. And dopamine has also played an important role, sort of evolutionary, from an evolutionary perspective, and in our survival as a species. And I'll talk about that in a minute as well. Dopamine is the neurotransmitter that is implicated in the drug high, and it is also the neurotransmitter that is a part of the craving that accompanies withdrawal. Now, there's lots of neurocircuits that are involved in drug abuse and addiction, and I'm going to speed through some of them very rapidly. The reward circuits, memory and learning, executive function, inhibitory control, and motivation and drive. And dopamine plays an important role in all of these circuits, but I'm going to spend much of my time focused on reward circuits and memory and learning, and this area of the brain that has lots of different parts and structures with many names that I am going to grossly refer to as the limbic system. So let's talk for a minute and start out with the reward circuitry. Drugs of abuse engage these motivational pathways of the brain that are really important in our experiencing rewards. There are events in our life that lead to the natural release of dopamine. Dopamine levels are elevated through activities that have been important for our survival as a species, like eating and sexual activity. Those things are pleasurable, so we kept doing them. Those things were pleasurable, so we remembered how to go about engaging in those activities, where to find mates, where to find food. And that's been really important for us. Drugs of abuse also cause a release of dopamine. All drugs of abuse cause a release of dopamine, and in some instances, you're looking here at amphetamines in particular, the release of dopamine can be much greater than what is experienced in engaging in a naturally reinforcing activity. And the brain, in very simplistic terms, likes homeostasis. So these spikes and drops in dopamine are things that the brain is struggling with, it's stressful, is always trying to adjust to. And that's part of what underlies some of the functional changes that occur within the brain that manifest themselves behaviorally. So this data is looking at the issue of natural reinforcers versus drugs as a reinforcer. This study was done to try and answer questions both about craving of drugs as well as about learning and associated priming of the reward system due to learning and associations. So what they did is they had controls, and they had cocaine addicts, and they showed them a series of images. They showed them neutral images that were videos of just nature scenes. They showed them images of drug paraphernalia, cocaine paraphernalia. And so what you see here is a composite of the control subjects and the cocaine users in an fMRI, looking at areas of the brain that were activated. So when control subjects who had never experienced cocaine use were shown cocaine paraphernalia, there wasn't much activation that occurred for them within their brains. But for cocaine users, there was a significant spike in activity just from seeing paraphernalia that reminded them about the high that they experienced when they used cocaine. They also took measures of craving, of drug craving from these cocaine addicts during the exposure to the nature video and during and after the exposure to the cocaine video, and they found that just seeing those images caused them to begin to crave drugs. Then they showed them erotic videos. The control subjects, as my colleague likes to say, their brains started lighting up like a Christmas tree. There was lots of activity because that is a naturally reinforcing event. But for the cocaine addicts, not so much. And you see there was much more activity in their brains in these different areas associated with reward from seeing images of cocaine paraphernalia than from a naturally reinforcing activity like sexual behavior. Memory circuits also play an important part in the ongoing use of drugs and are closely related to reward. This is data from the lab of my institute director, Dr. Nora Volkoff, and she was also studying cocaine addicts. And what she wanted to see if just seeing images that reminded you of your drug use was enough to cause a small release of dopamine. So you don't even have to use the drug. You just see something that reminds you of using the drug. Well, will that cause a small release of dopamine? And if so, what happens with craving? So she shows a nature scene video to these cocaine addicts. No release of dopamine. She shows the cocaine paraphernalia, and the ligand and the imaging shows that actually there was a release of dopamine just from seeing those images, and their craving scores went up dramatically. And we now have learned that even unconscious cues can elicit brain responses, that this learning and these associations are so strong that you don't even have to register at a conscious level that you're being cue-induced. So this is data from an investigator, and what she did was she took cocaine addicts and she showed a series of images very rapidly. So they didn't even really understand and couldn't fully describe what they were seeing as these images were coming in front of them. And she imaged them to look and see if brain regions that are an important part of the memory and reward circuitry were going to be activated. And what she found, and she showed them 3 sets of images. She showed them sort of nature scene. She showed them erotic images, and she showed them cocaine. And what she found was that there was increased activation consistently with the cocaine images versus the naturally reinforcing erotic images. Dopamine, as well as addiction, is also a part of motivation and executive control circuits. Dopamine is strongly associated with motivation and executive functioning via the regulation of frontal activity. And I'm not going to talk about this a lot, but what's important to know here is that over time, exposure to drugs of abuse and their neurotoxicity does lead to a decrease in metabolic activity and a decrease in function. So there's a fine balance between all of these connections that normally exist in the brain, between reward, motivational, learning, memory, pathways, and inhibitory control. And with addiction, this becomes severely disrupted, so that if you or I see something and we really want it, like I really wanted a second brownie, but I knew I was going to be given a presentation and I knew I probably didn't need that, I am able to put on the brakes and stop myself from having that second brownie, despite the fact that I know how good it tastes, I know how much I like it, I remember all of those kinds of things. drug addicts are not able to do that. They are not able to put on the brakes. We've developed treatments based on targeting these different neural pathways. We have medications that are available for the treatment of addiction, of alcohol, opiates, and nicotine. We do not have medications for the treatment of other substances, but we are in the process of trying to develop them. In some cases, what you see here may be targets for the development of medications, or some medications that we are currently testing or using to treat addiction. Likewise, we have behavioral therapies, and behavioral therapies also map onto these different neural pathways and are intended to either interfere with drugs' reinforcing effects with things like contingency management, or interfered with conditioned memories through things like biofeedback and desensitization. Our science has led us to identify some fundamental principles important to drug abuse treatment for those who are involved in criminal justice, and we have a publication that's available online. If you are interested, you can go to the NIDA website and you can download this publication. There's 13 principles and then a frequently asked questions section that tries to help address some of the most common questions that people have about treatment. I'm not going to spend a lot of time talking about this particular slide because I want to get to one more before I have to stop, but we know that the most effective way to address drug abuse problems is by thinking of drug treatment from a chronic care perspective, similar to any other chronic condition that is punctuated by periods of treatment and relapse like diabetes, asthma. And so there's a time where there are initial services that are prescribed, there are therapeutic interventions, but the piece that often gets lost and where individuals often have a difficult time is being able to sustain and manage the gains that they made when they were in some type of a treatment environment. This speaks to ongoing support and the need for ongoing intervention. My grandmother's 96 years old and she's diabetic, and she's been diabetic for over 50 years. If she had only gone into a healthcare provider 1 or 2 times and not been able to go back repeatedly to work on sort of sustaining and maintaining and tweaking her treatment over time, she wouldn't have lived to be 96 years old. To the extent to which we know and have learned that addiction is a chronic relapsing condition, we cannot expect them to have long-term gains and long-term abstinence from a single treatment episode. So what strategies have been tried with offenders who have substance use problems? Well, there's a lot of things that have been tried that don't work. Boot camps don't work. Intensive supervision, generic case management, lengthy incarceration without treatment, and harsh punishment have not demonstrated to be effective in helping with either criminal recidivism, or return to drug use. We do have many effective interventions. Residential therapeutic communities, for which many within URL's jurisdictions, if they go into the 500-hour drug abuse treatment program, have access to that. That is actually a residential therapeutic community. It is an environment that is intended to help them to learn different coping skills and decision making as they deal with their addictive disorder. Cognitive behavioral therapy is also effective. Contingency management, which provides reinforcement for achieving short-term goals that build toward longer-term behaviors, is effective. Medications work. Drug courts work and can be very effective. And then we have a lot of motivational enhancement interventions that are intended to help someone increase their own internal desire in order to participate in treatment. It is often the case that individuals enter into treatment under some form of coercion. Their spouse wants them to quit, or they're going to leave them. They're going to lose their children. They're losing their job. They're going to be or are incarcerated. And yet we know that regardless of the reason you come into treatment, if you are in a program that deploys these types of evidence-based practices, you can have very excellent outcomes. And I'm going to stop there.